to rationalize this denominator right here, what we're going to do is we're going to multiply this fraction by 1. So let's do that. We're going to do all of this. We'll do every step here. So if we multiply by 1, it doesn't change the value of the fraction. But the one we're going to choose is going to be this. We're going to choose exactly that denominator. We have a single term denominator. So we're going to choose exactly that denominator, right? Well, we're going to choose this is going to match this identically. And then the reason we do that is, look what happens. In the top, when we multiply the tops together, right, this 33 is outside times the 11 is inside. They're going to stay that way. 33 times square root of 11 over, but in the bottom we got the square root of 11 times the square root of 11. When you multiply square root by itself, the radical comes off and we get 11. Then this 11, the way this problem is written, will divide into 33 3 times. So we are left with 3 square roots of 11. Now, we probably don't need to write all of these steps, so what we would just do is maybe leave this top step out here and just write this. 33 over square root of 11, I would write as, okay, there's the original problem. I would rewrite it like this. Getting 33 square roots of 11 over 11, and then divide that, get that 3, so I'll get 3 square roots of 11. I don't really need to write this times 1 here. Problem number 12 is a little bit different than 11. In 11, we had only one square root, one term in the bottom, but now what we have is 2 terms in the denominator. So we're going to handle it a little bit differently. What we're going to do here is we are going to multiply this expression by 1 again. So 4 minus square root of 13, but the one that we're going to choose is going to be the conjugate of this denominator. So it's going to look like this, 4 plus square root of 13 over 4 plus square root of 13. And that gives us, now, left top times the right top. Let's just indicate it. So it's going to look like this, 12 parentheses times 4 plus square root of 13 over, now, in this denominator, we've got conjugates, and we know how to deal with conjugates. You square the first, put a minus sign, and square the second. So when I square the first, I'm going to get 16, right? Square the first, 4 squared is the 16, put a minus sign, and then square the second. And we know when you square a square root, the radical comes off, so we just get 13. That's a nice thing about multiplying conjugates together is you just square the first, put a minus sign, square the second, and if you happen to have square roots in any of them, you square a square root and the radical comes off. So now we've got 12 times the quantity 4 plus square root of 13 all over 16 minus 13 is 3, and then this 3, the way this problem is written, happens to divide into the 12, so we're going to end here with 4 times the quantity 4 plus square root of 13. We can leave it like that. Or you could multiply it through, getting 16 plus 4 square roots of 13. I think either one's fine. Problem number 13 asks us to complete this table. So we're going to put a number here, here, and here, so that this relation between x and y is not a function. Okay, we want not a function. How about fn for function? So we know what a function does. A function takes one element out of the domain and maps it to exactly one element in the range. Now, if it's, this would be a function. If it's not a function, we're going to take one element in the domain, that's going to be our left column here, and map that to more than one number in the range. And our range, that's our y column. So what if we do this? What if we put a number here, like just pick any number here at all. I'm going to pick 1. And now the way this goes, 1 goes to 4. But I want this kind of a thing down here where I want not a function. So I want 1 to go to not just 4, but to some other number, like maybe 5. So let's make a 1 going to 5. So that 1 would go to 4 and 5. Now, Now, we already have not a function, so just pick any number at all you want. Pick 1 again, or 2, or 3, or 4, any number. But because 1 goes to more than one element in the range, we have a table that does not represent a function.